Hey guys, welcome to the Each Global New Delhi workshop where we'll be going through what self is and what you can do with self, how you can integrate it in your project. Store everything inside the databases and you don't know where that data goes eventually. And um, well, obviously people know who you are when your data is stored in an unsecure manner, and there's so many leaks that target these databases and um, yeah, KYC providers. And well, if so the good thing about self is if nothing is stored, that automatically increases the security. So everything is stored inside your app, and there's less points in which a leakage could occur of your data. And obviously this is also great for user experience, since users don't really have to worry about their data getting leaked eventually. And yeah, so what exactly does self offer? So one thing is Sybil resistance, basically. So the idea is passports are difficult to obtain. So since they are difficult to obtain, obviously they provide a natural mechanism for Sybil resistance, because one thing is they are difficult to obtain. There's one issue per person among a country, and they're obviously easy to work with because they have a machine readable zone, those two lines at the bottom of your passport, and also an NFC chip for y- where all the signed data resides and the signatures and everything. Obviously, if you're not all countries have the NFC chip inside the passport, so we are also actively working on ID cards that don't have the NFC chip embedded inside them. So this is the civil resistance property offered because passports are naturally, or any national ID is hard to obtain and duplicate and be forged by a person. So what can you do? So one property is civil resistance, like one nullifier per user, and the other property is selective disclosure of your attributes. So for example, you can reveal your name, date of birth, issuing state, your nationality, and gender. So these are the attributes that are present inside your passport. So you can disclose them as it is, but in self we also offer some additional um, properties that you can disclose about yourself without actually um, revealing stuff about you. For example, instead of just revealing your age, which you can reveal that you're above a certain age. So it gives you a range of onlookers can have a range of ages to work with, but not the actual age. The same applies to a set of countries, right? You can prove that you're not from a set of countries without revealing your actual country as well, and the fact that you're not in any OFAC list. So the OFAC list is basically a US sanctioned list. So what it does is the OFAC list has it's basically a big list of all the offenders, criminal offenders, and so on of people. So for people who are looking at compliance, you can take a look at the OFAC feature provided by self to prove that a user that's registering with in your app is not part of the OFAC list. Also, this happens in a privacy preserving way. So if someone is part of the OFAC list, they will never be um, part of your protocol. So how exactly can you use the app, and how can you register or play around with self protocol? So before we take a look at how self actually works, take we can see here that here's the data provided by A16Z on the amount of people that are using passports and biometric ID cards and so on. But you can see that obviously not everyone has passports or biometric IDs, so we are soon rolling out support for Aadhaar, which would unlock 1.4 billion people to onboard with self, and along with your protocols as well. Moving on to how self actually works, what happens is for passports, at least what you would do is scan the MRZ, which is the machine readable zone. It's like the bottom two lines of your passport, and that essentially acts as a key to the NFC chip inside your passport. So You scan it, and then you use that to access the chip and authenticate yourself with it. So what self does internally is it registers users inside the protocol in an on-chain Merkle tree, where it's used later on to prove facts about yourself. So obviously for Aadhaar there's no chip, or there's no MRZ. So what happens, but if you notice, there's like a QR code inside the Aadhaar um, card. So this is present inside the Aadhaar PDFs or the OIDI PDFs as well. So what you would do instead is take a screenshot of those QR codes and upload it to Self, where we can decode your data and store a commitment of your data, so you can prove facts about yourself eventually in the future. The part of proving facts about yourself is called a disclosure proof. Essentially what you do is you reveal parts of your committed data, and what you're doing is you're proving the fact that you exist inside this tree, and as well as revealing data about yourself. So if so going back to a point about Sybil resistance, what happens is, since people can't register twice, they can only disclose so people can't really register inside the tree twice. So what also happens, what's like a natural follow to this, is that you can also disclose from a single commitment and not like multiple commitments, so you can't really have double proofs and so on. So how would you integrate self inside your app? So what happens is, as a third-party integrator, what you would do is, if you're building a website, you would have a QR code. So what this QR code initially represents is data about your app itself. And yeah, this is, or if you're developing an app, it's going to be a deep link that it's like a button that can eventually take that, when scanned or clicked, takes you to the self mobile app. And what the self mobile app does is it encrypts your data and passes it to a T, where a zero knowledge proof is generated. So the extent of your data is only stored until here inside the T, and then it's destroyed. So the app obviously verifies the attestation of the T, and if it is not what it expects, then it's obviously not going to pass on your data to the T. And from the T it goes to your contract or your endpoint. So you can either integrate self using using the on-chain SDK. So in this case, your contract will be called with T, or you can integrate us into a backend inside like an off-chain SDK, which is TypeScript, and also we also have a Go SDK that you can integrate in your app. Actually, what you would do is you would integrate this part, the QR code or deep link, which is the front-end SDK, and one of these SDKs, either the on-chain or off-chain one. Moving on to the bounties, we are offering 3-tiered bounty for the on-chain integrations. So the ones that use this backend SDK, the contract SDK. So this is like 3-tiered. So first price is 5,000 and 2,500 and 1,500 and so. So for off-chain, we would be giving there's a 1,000. We will be doing a dry run of this. So what exactly? So you can take a look at self.xyz/workshop. I'll be cloning that and running the app in a bit. But there's the app directory that has the front end, and it integrates the QR code SDK. And what it does is, it has data, like I said, it has data about your app, like your endpoint, where your proof should be sent to, and so on. And the mobile app scans this QR code, and what you can do is, once it scans, verifies the attestation of the T, it sends the ZK proof to your backend, in this case the smart contract. Yeah, let's take a look at the workshop. So there's if you go to self.xyz/workshop, so you can take a look here. It's we'll be cloning this here, and yeah, let's see the cell. I'm cloning the workshop. By the time it takes to get cloned, we can chat about the front-end SDK. So the front-end SDK is going to be self.xyz/QR code. Yeah, it's essentially a wrapper. It's like it provides data about your protocol, so that self knows where we can pass it along, where we can pass the proofs along, how we can verify it, whether it's on mainnet or testnet. So if you go here, you can see there's an app directory and there's a contracts directory. So cd into app and install the dependencies. You can see there's the self.xyz QR code library, and you can see it's on version 1.0.13, and there's other libraries, but the main one for the front-end integration is 1.0.13. So how exactly is the QR code library used? It's a simple component where you import a self app builder. It has data about your app, what version you're using, the name of your app, the scope, where your data should be passed on, the logo of your protocol, your app, and you can also pass along user IDs, which is a way you can identify your users. So you can either pass a UUID or an Ethereum address. In this case, since it's a simple example, we are passing the 0 address, and since we are using Ethereum addresses, it would be hex, but if you would use UUID, you would change it to UUID. Yeah, you can also pass some user-defined data, and your protocol can decide how to act based on this user-defined data. So you can see, actually, you can choose different types of configs to verify people from based on user-defined data. So, and this is the main part actually. So it has the disclosures. So what exactly are you disclosing? What this QR code tells you is your app wants to disclose that the guy has at least a minimum age of 18 and he's not inside the US. So you're not disclosing that the guy is in the US. You're disclosing, you're just verifying that he's not inside a set of countries. In this case is only a single country, which is the US. And you're also disclosing the nationality, which is not really necessary, or the gender. So you can see there's a bunch of attributes that you can also disclose apart from the custom ones that we added on top of, such as the OFAC or excluded countries and the minimum age. And let's also install the dependency. Essentially what the front SDK is, you build a self app builder that has data about what you want to disclose and so on, and this is inside a QR code wrapper which takes in the self app and optional on success and on error methods. So that's the front SDK, which is pretty simple. So keep in mind that we'll be only disclosing whether the guy is minimum age of 18 and his excluded country is he's not in the US. Basically, this is the front end, and you can check the contracts. So let's see, the contracts are done. Let's also install the Foundry library. Yeah, so that is the front end. This is, so we'll be taking a look at the contracts as well. So if you go into SRC, you can see there's a ProofOfHuman contract. Into the constructor, you'll see it accepts the hub address. So you can find the hub addresses for the protocol in docs.self.xyz. So you can find it in deployed contracts. So on mainnet, it's this one, and on testnet, it's this. So we are adding support for Sepolia right now. You can see there's a constructor that takes the hub address and the scope. So notice this scope is essentially an identifier for your application. Attackers doing traffic analysis from identifying people who do multiple disclosures in different apps. So different scopes kind of hide your identity within a protocol, and it makes you less vulnerable actually to traffic analysis attacks. So you can see we accept a verification config. So what verification config is, it's a way of enforcing your config on chain. So you saw our app wants to disclose um, the fact that the person's minimum age is 18 and he's not inside the United States. We want to enforce the same constraints inside the contract as well. This verification config does is it holds those constraints, and we first what you do is transform it into something that can be used by the hub. So you can see the hub takes this verification config and gives you an identifier. So it's a deterministic identifier for the config, and you can use this later on to do different kinds of proofs for this config in the future. And the constructor where you set your verification config and verification ID. And there's also, since this is going to inherit self-verification route, there's a couple of methods you have to also implement. One is the custom verification hook. What this does is once a proof gets verified, you will get access to the disclosed outputs, which is going to be the name, ID number, nationality, and so on. If it's not disclosed, it's going to be an empty array, like an empty string. But if it's disclosed, then you can work on top of that. ID. So this gives you a bunch of parameters. So there's the destination chain ID and user identifier and the user defined data. So what you can do is you can return different types of verification configs based on, let's say, different types of data. We're working on top of user defined data, and if user defined data was, let's say, 1, well, it's a byte of 1, then use one kind of verification config. Let's say return a config that checks for above 18, and otherwise you can return a config that does something else. So that is one way of using user defined data, and it doesn't hold you to just one verification config, and you can choose different ones based like dynamically. That is all you have to do in the contract. So there's the constructor, and there's the custom verification hook that gets called when the proof gets verified, and you basically have the choice to execute some code after some verification, like think of it as a callback. And there's the get config ID function that you can dictate the protocol to do a particular kind of verification based on these constraints. So these constraints, you can see when we create the contract inside the script, and you can see there's a deploy ProofOfHuman.sol. So what constraints are we setting here? So there's like forbidden countries that only has the United States, one forbidden country inside the set, which is the United States, which is the same as the front end. And there's also the minimum age 18, which is similar to what we set in the front end again. So these two constraints have to be the same because it's something you're trying to enforce on chain. And yeah, we go on to create the ProofOfHuman contract, and you can do disclosures on it. So we can deploy this contract real quick. So if you go to the .env, you'll see there's like a bunch of env that you have to. So I'm going to copy this into the .env folder, and this is something I loaded just before the thing, and we don't need a API key. We are not going to verify a contract. This is how the contracts work. Like, this is all you need to deploy the contract. And if I just deploy the .scripts, you can see that it's compiling, and then your contract is going to be deployed eventually. Yeah, so until it gets deployed, we can take a look at what the script does. Script and deploy ProofOfHuman. So what we're doing is compiling and um, deploying the contract, and we are checking the scope seed. So one thing about the scope seed is that it's the scope, like I said, the scope is an identifier for your application, and it's a hash of your contract address and um, your contract address as well as a seed you can choose. So in our case, the seed we chose was um, self workshop here. So this is also going to be similar to in what you have in your front end, which is here. So you can see it uses the same self workshop, if it's not different of course, but it's the same. And you can see our contract got deployed at this address. So we can go ahead and use this inside our QR code. So the QR code expects an endpoint, which is going to be your contract address. So we can switch over to here, new file.env, and this is here. This is the contract we just deployed, and we can run the app now and do a discrete npm render. So you can see that there's a QR code over here, and what this contains information, what information contains is basically the config you set for your protocol, as well as along with the config it has data about your contract address and so on. So I have passport configured here, so you can see there's multiple passports you can choose, and what I'll do is I will scan this QR code and I'll do a disclosure. So you can see there's a bunch of checks that have to happen before your disclosure happens. So yeah. So I'm going to verify now. It's proving, and you can see it got verified. This is a document that is Indian. You can see that obviously I'm going to pass the checks because I'm not part of the United States. I can also change to a document. So we have mock documents inside Self that you can create for developing and testing. So I have one document that is from the United States. Can use that document and see if we can verify ourselves inside our protocol or not. Select this document. Let's wait until this happens. It's now asking us to verify, hold to verify. So if I hold this, yeah, you can see the proof failed. And actually the proof could never get created in the first place because you're part of this list of countries that you're not supposed to be a part of. So that proof actually never even got to your contracts. So basically can't create a proof in the first place. And that would be it for the contracts example. So So one thing about the scope seed is you can head over to Tools.self.xyz, and you can generate the scope for your application by, so for example, the scope seed is self workshop and the endpoint is this. So make sure to use the checksummed address. Actually, what anything that's consistent from the front end and back end, and you can see this would be similar to your application. I cleared those logs, but you can you can see inside the script what it does is it sets the scope again. So because the scope depends on the contract address, we can't set it in the first try. You have to deploy your contract, get the contract address, and then set the scope again. So you can see our ProofOfHuman contract has a setScope method where you can set the new scope. So this is precisely what this is. You can either do this, use Tools.self.xyz, or you can do what this script does, and let me see where that is. Yeah, so what this script would do is, yeah, use the library and hash it with the checksummed address and the scope, and it would log the same um, number. And what you can do is, to your contract, set the scope to the number you get either from this or from the tools.self.xyz website. And yeah, you can also see the docs for how backend verification works. So if you head over here, you can see it's, so the front part remains the same, but you also have a new backend verifier that you can set the configs for. So all of this is same. You know what scope is. This scope would be the scope seed. You know the endpoint, which is the URL of your um, API, along with like the path, like resource path, whether you are using mock passports, the allowed IDs, and what this config storage is basically a store for all your configs. And what you can do is you can store multiple configs inside the storage and use them based on a user defined data, or yeah. So how would you use this inside an API? So once, so you can see here that inside your config store you can set different configs. So there's a strict verification, let's say, for minimum of 21 age, and there's standard verification for minimum of 18. And you can, let's head over to quick start and see how it uses it there. So this is creating the config store, like the backend verifier, and you would set up an endpoint that would receive these four inputs, so the attestation ID, proof, public signals, and the user context data. And you would call the self backend verifier with these parameters, and you can work through the exact same data type as essentially this callback. So it's essentially the same as this struct. You can work on top of, so it's your choice if you want to use off-chain or on-chain verification. And yeah, that would be it for backend. Backend is a bit more simpler than contracts. So that would be it for our dry run. And yeah, so going back to our slides, you can see yeah, so that was the code examples. And thank you for attending this workshop. We are excited to see you in ETH New Delhi and what projects you will be creating using Self. You can go to our website or start us on GitHub. And thank you.